Okay, let's have a look at the one proportion test using this example of the student debt. Now, the question was whether or not student debt has increased since 2000. That's really the question that we want answered, and notice that that becomes our alternate hypothesis, and our null hypothesis is generally written as the status quo. There has been no change. So we were told in the problem that 54% of students graduated with debt. That's what the number was in 2000. That's my status quo. The question is whether or not the proportion now has increased, our alternate. Okay, we take the information that's given in the problem. We were simply told that 58% of our sample of 200 people, 200 graduating students, graduated with student debt. And if we work backwards, that's actually 116 of the 200. So if we weren't already given the sample proportion, we might have been told that, for example, 116 of 200 surveyed graduating students graduated with student debt, and that worked out to a sample proportion of 0.58. That 0.58 needs to get compared to the proportion of students with debt back in 2000. So when we do the calculations for a one sample proportion or one proportion test, we calculate a z-score, and the formula is shown here. We take our sample proportion, which is the 0.58, we subtract that by the proportion that's in our statement of hypothesis. Do not get these confused. Don't switch this around and have the 0.54 minus the 0.58, or you're going to get different answers. You will end up with a negative z-score, and that will change the water on the beans. So it's the sample proportion minus the population proportion, the population parameter of 0.54. And also take note that in the bottom of this calculation, the P naught here is the number that appears in our statement of hypothesis. So this P value right here should be 0.54 and not 0.58. Okay, we plug this in. We know 200 students were surveyed, and we get a test statistic, which in this case is a z-score of 1.14. And what we really want to know is what is the probability of getting a test statistic of 1.14 or bigger. Now, why do I say or bigger? Because the question wants to know whether or not student debt has increased. So if I was doing this by hand using tables, I'd go in and I'd look at my z-score of 1.14, and I'd find the area to the right. So that's one way I could do it, and I think in D2L I've given you tables that give you areas to the right. If you only had a table that gave you area to the left, you'd find all this white area, how much area lies from 1.14 back this way to the left, and you take that value and you would subtract it from 1, and what you would get would be this area of 0.128. Okay, so my p-value is 0.128. So what does this really mean? Well, the p-value is always contingent upon our null hypothesis. So assuming our null hypothesis is true, we don't know that, but assuming that it's true, the probability that I could get 58% of my sampled students graduating with student debt, that probability is 0.128. Or another way I could say it is that there's a 12.8% chance that I could get a sample proportion of 0.58, given that my population proportion has not changed, that it is 0.54. Okay, and then once I get that p-value, I now have to compare that p-value to something. And I don't know if I stated it in this problem. Let's go here to slide 21. and we're told suppose we have to make our conclusions at a 5% level of significance. Now 5% level of significance corresponds to a 95% level of confidence. But when we go to make our decisions, we compare that p-value to the level of significance. If the level of significance is set at 5%, then alpha is 0.05. The question you always should be asking yourself, is your p-value less than or possibly equal to your alpha? So we have 0.128. Is 0.128 a smaller number than 0.05? The answer is clearly no. And if the answer is no, as it says right here, we fail to reject the null hypothesis. So I'm failing to reject, going back up here a slide, okay, I'm failing to reject this statement. In other words, I have to retain it. So, has my student debt changed or increased, since 2000? No. There's not enough evidence for me to say that. The evidence does not support the HA. On the other hand now, the evidence doesn't prove this statement to be true, but the evidence is not strong enough to prove this one to be true. So the way we look at this from the point of statistics, and I know this is confusing, because that p-value is not smaller than my alpha, what it really means is I have to conclude that the proportion of students who graduate with debt has not increased significantly since the year 2000. Okay, on this slide right here, I've shown you how to go about doing this in Minitab. So if I go to Minitab, let's have a look at this. I've got Minitab open right here. We go into basic statistics and we're doing the one proportion. Now we already used this for confidence intervals as well, but you can use it for tests of hypothesis. So it's a one proportion test, or it's called a one sample proportion. We don't have any raw data, we have summarized data. We had 200 students who were interviewed, and 116 of them said that they were graduating with debt. Now, because we're performing a test of hypothesis, we have to click in this box right here, and we have to put in here where it says hypothesized proportion. That's the number that's in your statement of hypothesis. It's the number that's written as your HO. So we're saying our HO is equal to 0.54. We go to options. You do not have to change your confidence level if all you're doing is a test of hypothesis. It will not impact your p-value. Now, what do we want to know? We want to know, was our proportion greater? Has the percentage of students graduating with student debt increased above that 54%? And so that you get the same answer as what you might if you worked it out by hand, let's assume that we're using a normal approximation. If I click OK to that and OK again, here's what I get. And you should always go and have a look at this printout. So first of all, you've told it, there's your null hypothesis. What is your alternate hypothesis? Please check this. Your alternate hypothesis is greater than. Okay, we gave it some data of 200 people surveyed, 116 of them graduated with student debt. There's my sample proportion worked out. Minitab gives me my test statistic, and it gives me my p-value. And really at the end of the day, what are we interested in? We're interested in the p-value. And the question is always going to be, is the p-value less than or possibly equal to your level of significance? If my level of significance is 5% or 0.05, this p-value is not smaller than 0.05. And if it isn't, then I failed to reject my null hypothesis, and I'm going to conclude that there has been no change in the level of student debt. Now, yeah, student debt has increased according to my sample. It's 58%. 58, yeah, is bigger than 54. But from a statistical point of view, that change is not significantly large enough for me to say that there was a real change. So my conclusion is there's been no real change since the year 2000.